Welcome to the course of Engineering Chemistry 1. The topic for today's class is Nanomaterials Introduction. General objective. Students will able to understand the importance of nanomaterials. The first specific objective represent nanomaterials, nanoscience and nanotechnology. The second specific objective infer the advantages of nanomaterials over macromolecules. The third specific objective classify the four types of nanomaterials based on their dimension. Let's see what is nanomaterial. Materials that have size in the range of 1 to 100 nanometer in at least one dimension are called nanomaterials. So by definition, you have three dimensions like x-axis, y-axis and z-axis. According to the definition, you should have at least in one dimension, the range should be 100 nanometer. So let's see here, we have three dimensions and you can see in one of the dimension, the range is 1 nanometer, which falls in this category 1 to 100 nanometer. And in the two dimension, it is outside the nano range. In the second example, you have in two dimensions, the range is 1 to 100 nanometer and in one dimension, it is outside the range. The third example, you can see all the three dimensions are in the nano range. So these three categories are coming under the nanomaterials. So there is another category, you can see all the dimensions are outside the nano range because everything is in millimeter. So this is not in the nano range. So such a molecule or atom is not classified as a nanomaterial. What is nanoscience? So nanoscience refers to the study, manipulation and engineering of matter, particles and structures on the nanometer scale. So for example, here I take a carbon nanotube and I am going to study about it. Then it is called nanoscience because you are studying a material which is in nano range. Then what is nanotechnology? Nanotechnology is the application of nanoscience in which you produce useful products out of it. So when you are making a product which is in nano region, then it is called nanotechnology based product. So that is the wide application we are using in the current world. Nanomaterials are of several kinds and one among them is inorganic nanomaterials. When I say inorganic nanomaterial, it could be metals like silver nanoparticle, gold nanoparticle, palladium nanoparticle, like that. And then you have metal oxides or metal hydroxides, example zinc oxide, copper oxide, titanium oxide, and then ferric oxide, or else it could be metal chalcogenides. Chalcogenides are compounds in which the compound is made of oxygen family like sulfur, selenium. These are all oxygen group family. So metal chalcogenides are also obtained in the nano range. You have organic nanomaterials in which you have only carbon and hydrogen. Example are micelles, liposome, hybrid, dendrimer and nanosphere and nanocapsules. There are also carbon-based nanomaterial, which are all pure carbon. So you have only carbon and no other elements are there. Example, graphene and fullerenes. Next, we are going to see the advantages of nanomaterial over macromolecules. So there are two primary factors which make nanomaterials more superior than the macromolecules. So the first factor is surface effect, and the second factor is quantum effect. So surface effect is nothing but when you reduce the size of a molecule, you have more surface area. In other words, the fraction of atoms at the surface will be more. So because of this, the nanomaterials are superior over macromolecule. And the next one is quantum effect. In the quantum effect, we discuss about the energies. Energies are usually continuous when it is a bigger molecule. But when we go down in size, it will be discrete. And because of this change, we have some effects which makes the nanomaterials more effective. Let's see few properties of nanomaterials, how they are different from the macromolecules. The first one, we are looking at the melting point and the lattice constant. Reduced melting point, which means when you compare a bulky material with a nanomaterial, the melting point will be reduced. This is because you don't have intermolecular force between the molecules. For example, you can look at the graph here, melting point versus radius of a particle. So you can see that for a tinier molecule, the melting point is lower. As the size increases, the melting point also increases. Similarly, the lattice constant decreases with the increase in the number of atoms. Mechanical property. So mechanical property increases for a nanoparticle. This is because of the reduced probability of defects. When you go down in size, the probability of defects will be lesser. As a result, the mechanical property will be more. So you can see here, when the diameter is 289 nanometer, the hardness of this particular material is 30 MPa. But when we go down in diameter, which means we are going down in size, then the hardness increases. So this is mainly due to the reduced probability of defects in the arrangement of the atoms in the lattice. Next, we look at the optical property. The reduction of material dimension has pronounced effects on the optical property. So the change in the optical property is due to two factors. The first one is quantum confinement of electrons, which tells that your energy level spacing will be increased. So when you increase the energy level spacing, automatically your wavelength will go down, because energy and wavelength are inversely related. So the optical absorption peak of a semiconductor nanoparticle shifts to a shorter wavelength, which tells that the energy level spacing is more. Next, the surface plasma resonance. So this is due to the smaller size of the nanoparticle when compared to the wavelength of the incident radiation. And because of this, there will be a change in the color. For example, the color of metallic nanoparticles may change when we reduce their size magnetic property of nanomaterials will also show difference from the bulky material. For example, when a material is bulky and it is acting as a ferromagnet, but when we go down in size, it turns into be a super paramagnetic. Next, we look at the electrical conductivity. So the electrical conductivity decreases for a nanomaterial. This is due to the surface scattering. So you have surface scattering, as a result the electrical conductivity decreases. But if you want to increase the electrical conductivity, what we can do is we can make more ordered in the microstructure. If you go to the microstructure level, you need to have more ordered state, then you can improve your electrical conductivity. Self purification. So self purification is nothing but purifying by itself. So this can be done by going down in size. So when you do that, you can remove the impurities as well as the defects will be lesser. Next, we will look at the classification of nanomaterials. So nanomaterials can be classified into 4 types. So the first one is 0 dimension, the second one is 1 dimension, and the third one is 2 dimension and 3 dimension. First, we look at the 0 dimension. So in 0 dimension, you have nano dimensions in all 3 directions. So you have 3 dimensions, x, y and z. In all the directions, if it is in nano range, then it is called 0 dimensional. So these are the examples: quantum dots, fullerenes, gold nanoparticle. So mostly such materials will exist in spherical shape, and their diameter are usually in the range of 1 to 50 nanometer. So let's look at the quantum dot. So here you can see in all the 3 directions it is in the nanometer range. Next, one dimensional. In one dimensional, in one dimension you have the range in outside the nanometer. For example, so in 2 dimensions you have the size in nano, and in 1 dimension it is in milli. So if it is outside the nano range in 1 dimension, it is called one dimensional. So example for such kind is metal nanorods, and then carbon nanotubes, and then gold nanowires. So these are all one dimensional nanomaterial because they are in outside the nano range in 1 dimension. If 2 dimensions are outside the nano range, then it is classified as 2-dimensional nanomaterials. So 2 of your dimensions are outside the range of nano. Example for such kind is mostly planar molecules like carbon coated nanoplates, layered nanoparticles, and then the graphene sheets. 3-dimensional nanomaterials. So in this kind, all the 3 dimensions are outside the nano range. So the examples are liposomes, polycrystalline and dendrimers. So in these cases, you have all the 3 dimensions are outside the nano range, which is 1 to 100 nanometer. So the mind map for today's class: we started with nanomaterials, and the definition says in at least 1 dimension you should have 1 to 100 nanometer, so that it can be classified as a nanomaterial. And we discussed about the advantages over macromolecule. So the two factors which makes the nanomaterial advantageous is surface effect and quantum effect. Next we discussed about the classification. The classification we discussed four kinds: 0 dimension, 1 dimension, 2 dimension and 3 dimension. So this is based on the size of the materials in the three directions. Thank you.